Okay, so large vat is initially filled with saltwater solution. Solution at a higher concentration of salt flows in the vat, and solution flows out of that the same rate. Number of pounds of salt at time t is modeled by the function a that satisfies the differential equation dA dt. At time t equals 10 minutes, the vat contains 50 pounds of salt. Write an equation for the line tangent to the graph of a at t equals 10. Use a line tangent. Use take length to approximate number of pounds for that at time t equals 12 minutes. So this is tangent equation followed by linear approximation. Right? So tangent equation, we typically I know order pair is usually x, y, but in this case, we have to make some adjustments. Our order pair is now going to be what? T comma a, yeah. And if you have different variables, it's always going to be t with another variable. Usually that second variable is in uppercase. Okay. So that means ultimately, instead of y minus y1 equals m times x minus x1, it's going to be a minus a1 equals m times t minus t1. So it looks a little bit strange, but hopefully we can make that adjustment without too much trouble. Okay, so your order pair is what? 10 comma 50, okay. And then to find the slope, just insert that information into the dAdt, right? Yeah. So dAdt, it looks like it's only taking the a variable, so just insert the a variable, a value in. We can work towards our tangent equation. Order pair 10 comma 50, slope only needs that 50 in its derivative. Okay, so now that we have our tangent equation, how can we finish the problem off? Yeah, plug 12 into the t variable of my tangent equation. So that will give me my linear approximation. So sometimes linear approximation, it may not, doesn't have to be a decimal value. It can just be any different value that is not at the location of that tangent line. So again, we're using that squiggly line to indicate that, you know, this is not the actual value of the at 12, because we're not given a of, well, we're not given a of t, not until part B. So this is not the actual value, but instead they just want us to use a tangent line to give an approximation of that actual value. Okay. Part B. Show that A of t is equal to 300 minus 250 e to the 0.2. So that satisfies the differential equation. So we have to go through our work and solve this differential equation. So separate the variables, right? But instead of y is on the left, x is on the right. Now, what do we want? What do we want on the left side? A on the left, and then B's on the right. Okay, so let's just go ahead and set ourselves up for cross multiplying. Okay, wait a second. Different. That's not, I'm sorry, we're not solving differential equation until part C. Part B here. Okay, sorry. So we start with this, and we want to show that this leads to this derivative. Not bad. Okay, so we want to start off with A of t. So when you find the derivative, so A prime. So 300 goes to 0. 250 stays. E to the u becomes what? E to the u times u prime, right? So e to the u times u prime. So the derivative of my exponent is just what? Sorry about that. Yeah, negative 0.02. Okay. Clean this up here. 250 times negative 0.02 gives us 5. So I worked up to the point where I'm not quite seeing how these are linked up yet, but maybe I kind of work from both sides, right? Because I know that dA dt is in terms of A here. So what if I replace A with this 300? So I should be able to hopefully work my way down and at least, kind of work from both sides just to show that they're equivalent to each other. So I'll replace A from my dA dt with this 300 minus 250 e to the 0.2 minus 0.02 t. And I'm just going to algebraically or numerically try to clean this up and work from both sides and show that they're the same. So I've worked up to a point from A of t to A prime, and now I just want to be able to get that dA dt to look the same. So I replaced that A with that expression in terms of t. Right. And then if I distribute that negative 0.2 through, I'll get negative 0.02 times 300 is negative 6. Negative 0.02 times 250 is positive 5. The 6's cancel out, and I'm able to see that, okay, they're the same because I'm able to prove that they're equivalent to each other. Okay, part C. The flow of solution into the vat is stopped and the solution is drained. The depth of the solution in the vat is modeled by the function h, which satisfies the differential equation dHdt equals negative k root h, where h of t is measured in meters. If the depth of the solution is 60 meters at time t equals 0 and 4 meters at time t equals 30, what is h of t in terms of t? So we want to solve this differential equation. I know that k looks intimidating, like what to do with that k? Treat the k like a coefficient, like a numeric value. Okay, so don't treat it like a variable. It's just some number that we don't know the value of yet. But there's no need for a product rule on the right side. Just pretend like it's a 3 or a 5 or 6, just some number that's going to hang out with the h. Okay, so part C. Again, the first thing I like to do is cross multiply, just so I can get everything up to the same level, and then I can decide what needs to be moved to get full separation. So I cross multiply, dh times 1 is equal to negative k root h dt. What's out of place? What moves? Root h, yeah. Root h is removed. Anything else? That's good, right? The k will stay with the t because it's a number. It's a constant. So anything that does not have to be on the left side, we want to keep it on the right side. The left side, you want to try to keep as minimal as possible. So we'll divide both sides by root h. If you want, you can pull that negative k out in front. And that as a reminder that right side is power rule. That k is not going to influence my antiderivative. It's just going to hang out. But the left side, okay, well, first we have a full separation, so we can move on to our antiderivative stage. What rule do we use on the left side? Okay, power rule. Why not natural log? I mean, the variable's in the denominator. Right, it's not a 1, right? If it was denominator to the first power, that's the only time you use natural log. Any other time, you got to bring it up to the top. We got to go through a power rule. So power rule, h to the negative 1/2 becomes h to the 1/2 over 1/2. K, negative k stays, the 1 becomes t, but we don't want to forget what, plus c. Because anytime we take the antiderivative, there's always a plus c that shows up. Yeah. Technically, it shows up on both the left side and the right side, but we just always put it together on just as one constant on the right side. All right, and also it's indefinite integral. There's no bounds here, so there's always a plus c with indefinite intervals. Okay, so the calculus is done. Now we We have some additional steps though. Not only do we have to solve for H, we got to solve for C, and we also need to solve for K as well, because K is a value that we have to resolve. So that's why there's a lot more information in this problem. But I like to, let's see what we can do. That 1/2 is really a 2, right? So a 2 H to the 1/2 equals negative KT plus C. Let's just see what order pairs we have, and depending on which is more convenient, we'll solve for whichever variable or value it will be easiest to solve first. Okay, so it says that the depth of the solution is 16 meters at time t equals 0. So we know there's a 0, 16 that we can work with. And there's also another order pair. What? But what comes first though? Right, 0, 16. But what's the other order pair? Is it 4, 30? 30, 4, right? So the t comes first. Okay. But yes, you're right. The order pair that will be easier to plug in is going to be that 0, 16, because that 0 is going to allow us to get rid of a variable quickly and solve. We don't know which variable is going to come first, is going to solve first, but we know this is going to be the easier or the more useful one to begin with. Okay, so we'll start with that 0, 16 and see what that gets us. And the reason why they provide us 2 order pairs is because they know that we got to solve for the K and the C. Okay, so 0 in for T, H in for 16 in for H. Okay. How do I resolve this? What is this going to equal to? Yeah, so we always take care, right? Anytime there's a radical or exponent, we got to resolve that first. So that becomes 4. Square root of 16 is 4, and then you can multiply with the 2, 8. Okay, so we're making some progress. We have our C value. Now let's go back to our equation. We'll update the C and then plug in the order pair again. That should allow us to solve for K. So second order pair, 30 in for T, 4 in for H. See if we can get to our K value. Uh, 4 to the 1/2, that's square root of 4. Square root of 4 is 2. 2 times 2 is 4. Subtract 8 from both sides. Divide by 30. So we have our K value. Let's go back to where we make that substitution. And now we should be in the clear. Now the only thing that's left to do is to solve for H. Okay, so 2 things here. We can divide by 2 and we can square both sides, right? But dividing by 2 is the same thing as what? Multiplying by 1/2. Feels a little bit easier to do it that way. Dividing by 2 with negative 2/15 just feels like a messy complex fraction. So if I instead multiply by 1/2, it just feels a little bit easier to distribute that through. So 1/2 times negative 2/15 becomes negative 1/15. And then 1/2 times 8 is 4. Square both sides and we can get H by itself. There's no need to expand this out. You can leave it in this form.
Okay, page 18. Go ahead and read the problem and see if you can make sense of at least the first few parts. Okay. On Saturday before Mother's Day, drugstore has a large selection of greeting cards for sale between 0 and 10 hours. The number of cards left on the shelf at time t hours is changing at a rate of m prime of t, measured in cards per hour. The function m is twice differentiable, and m of 7 equals 44. So we know that so at these times, we see that people are buying these cards, so the cards are being removed from the shelves at this rate, at negative 10 cards per hour, negative 12 cards per hour. Okay. So approximate m double prime of 6. We don't have m double prime, but we have m prime, so we can just take the what? Take the slope. Yeah. Okay, so we're forced to have to use 6, use 4 and 5 because, I'm sorry, 5 and 7 because those are the closest order pairs. We know that m prime is cars per hour. So m double prime will be cars per hour squared. It's a positive 1. Question so far. It says using correct units, interpret the meaning of m double prime of 6 in the context of this problem. Now, I think what some students do is they see second derivative and they don't know exactly what to say, so they use the word acceleration. So acceleration will be good for particle motion, but it doesn't quite fit the context of this problem, right? We don't do acceleration when we're talking about cards coming off the shelf. So what does that mean? What does that positive 1 mean in the context of this problem? Yeah, that's right. The rate at which the cards are removed from the shelf is increasing. So basically, you just have to describe this rate and then add the word increase or decrease to give it the fact that there's a rate on top of the rate. Okay. So again, the tendency is we want to always say acceleration for second derivative, but we got to word it a different way if it's not particle motion. So the rate at which cards left on the shelf, that is describing m prime. But then you add the word increasing, and that's going to give it that second derivative. Right? You're basically saying rate of a rate in a way that, and also if you just say that the rate of a rate is changing, that's not quite good enough, right? So you want to say the word that the rate at the cards at which cards are left on the shelf is increasing. Okay, so rate of a rate is not it's getting closer, but it's not specific enough. Saying it this way shows the grader that you understand what it really means. Right? Part C, write an equation for the line tangent to m at t equals 7, and then use the tangent line to approximate m prime of 9. So they give us an order pair. M of 7 equals 44. And then we also know m prime of 7 is negative 12. So there's your there's the information that you need to create your tangent line equation. You got your order pair, and you got your slope. So dew point slope, instead of y and x, we got to use t and f. Okay, so now that we have our tangent line equation, we can use whatever value they want us to approximate. So I'll put in a different t value into our tangent line equation, and we get our approximation. Okay, part B. Is there a time between 0 and 7 such that m double prime of c is equal to 0? We don't have m double prime in front of us, so what theorem are they trying to get us to use here? Rolle's theorem. Right. So basically, Rolle's theorem says I can guarantee a slope of 0 if I have two endpoints that are the what? The same. So do you see any same endpoints? Yeah, 4 and 7. There you go. So because 4 and 7 shares the same m prime value, you know that if my m prime is negative 12 and another m prime of value is 12, negative 12, then on that order, on that graph, the graph has to loop down and come back up, or come back, go up, come back down. It's got to hit a slope 0 somewhere between, right? So we got to apply Rolle's theorem there. Okay, so we want to state all the conditions. We know m prime is continuous on the closed interval with brackets. We know m prime is differentiable. And imagine this is the m prime graph. If I have negative 12 and negative 12, the only way to connect it is with, it's got to have a slope 0 somewhere between, and that's going to guarantee my m double prime being 0. Okay, part F, use right Riemann sum. So you just have to spell out each of your subintervals, identify the width, and then pull the appropriate heights, and then do width times height for each of the rectangles. Now, do we keep all the negative values? Yes, okay, because there's no absolute value, right? It's not asking, so we want to just basically do displacement. So whatever sign they give us, we got to hold on to it.
Part G, evaluate m double prime of 7 minus 3t. Oh, sorry, the negative 84. What that means is that over the course of that 7-hour period, 84 greeting cards have been removed from the shelves, or 84 greeting cards were sold. So that negative 84 means there's 84 less cards on the display than there were before. Okay, evaluate the depth interval from m double prime of 7 minus 3t dt. Show the calculations. So we've seen this before, I think on the previous quiz. Well, we have to go through what method here. Start with what? U substitution. Yeah, we got to get that antiderivative a little bit cleaned up, right? So let's start with U substitution. Once we get it nice and clean, then we can take the antiderivative, and then we can work in the upper and lower bounds. Okay, what's our U value? 7 minus 3t. I think on the previous quiz, some students were trying to do chain rule. Now, chain rule is for derivatives, right? The antiderivative version of chain rule is U substitution. All right, we got to go through U substitution here. So we want to replace the parentheses in terms of U. We want to replace dt in terms of du. A negative 3 in the denominator is going to pop up. Let me show the work so it doesn't feel as messy here. Looks a lot cleaner. I can push that negative 1/3 out in front. So now we can take our calculus step. M double prime is going to rise up to what level? M prime. Okay, so keep that negative 1/3 with it. Now I want to work in the bounds, but I think it's a little bit cleaner if I can bring that U back in terms of T, and then I can, sorry, my bad. Yeah, once I have M double prime ready to go, take the antiderivative, becomes M prime. Calculus is done, but I still want to resolve this U because I don't want to plug the 1 in for U because these are not the same variables. So replace the U back in terms of T. So now you're free to use the 1 and the 0. Okay. Look at the table. M prime of 4 is negative 12. M prime of 7 is negative 12 as well. Okay. So on Monday, I'll be checking pages 15 through 18. I'll send out a reminder on Sunday, so just to remind, just so that over the weekend, you know, I'll be checking. On Monday, we will do the remaining pages. We'll try to do more remaining pages. Whatever we don't get done, I can do as morning review for Tuesday, and then I'll check the remaining pages in your packet 3 on Wednesday, day after the quiz. Guys, I'm seeing less and less phones up on the wall, so Monday, want to see all the phones back on the wall. Okay. Okay, don't get your phone.
This is my phone.
Great, thank you. No, oh, sorry. Relative fortune. Yeah, that's not right. As these grades are already in the grade book, that was.